This week brings the equinox, the start of spring. We can feel that we're traveling around the sun because of the seasons: winter, spring, summer, autumn, then winter again. With its tilted axis, the Earth faces the sun at different angles. When the Earth is here at noon, the sun is vertically over the southern hemisphere. Down under, it's summer. At the same time, for most of the day, the northern hemisphere is in shadow. It's winter. Then, as the Earth travels on its orbit, the line where the sun beats down vertically rises towards the equator. The day when the sun is vertically above the equator, that's the equinox. Equal sunshine for the north and south. For the northern hemisphere, spring is starting. As the Earth continues its journey, the line where the sun shines vertically rises further north. And in June and July, the northern hemisphere leans towards the sun, and its rays reach us at a hot angle. It's summer. As our voyage continues, the sun moves back down towards the equator and crosses it on the 23rd of September, the autumn equinox. It returns below the equator and winter is coming. But today, the sun is on the equator and spring is beginning. This equinox period brings us the spring tides. The pull of the moon attracts the water in the oceans. If it's a half moon, it pulls in this direction, while the sun pulls in another direction. These two diverging pulls cause only small tides. However, if the moon lines up with the sun, they pull together and give us very high tides. On the day of the equinox, directly over the equator, the sun adds its pull to the Earth's centrifugal force, and that triggers our equinox spring tides. Another factor is important for tides: the distance of the moon. The moon's orbit is an ellipse. Sometimes the moon is distant and sometimes it's close. The closer the moon, the higher the tide. Sometimes the strongest tides don't come with the equinox, but on days when the moon is closest to the Earth. If we look at the sun at the equinox point on the first day of spring, it appears in front of the constellation of Pisces. Over the millennia, the Earth's axis draws a circle, slowly changing its angle. Obviously, the equator also changes its angle. Now, if the equator changes its angle, the day of the equinox will also change, since that's the day when the sun is right above the equator. For the last 3,000 years, on the day of the equinox, the sun has been in front of Pisces. Now it's edging away from this constellation. Gradually, over the next few centuries, on the day of equinox, the sun will no longer be in Pisces. It will shift towards Aquarius. That's why we hear about the dawning of the age of Aquarius. Astronomers call this the precession of the equinoxes, the sun shifting slowly from Pisces to Aquarius. When we talk about Pisces and Aquarius, we mean constellations, patterns of stars, not astrological signs. Astrologers haven't readjusted their signs to the shifting equinox. So over about 2,000 years, astrological signs have moved from one constellation to the next. Roughly every 2 years, the Earth overtakes Mars, the red planet, moving on the outer orbit. The Earth, on the inner orbit, is faster than Mars and overtakes it every 2 years. Catching up, the Earth slips between Mars and the Sun. When the Sun, Earth, and Mars are in line, Mars is in opposition to the Sun. Seen from Earth, just as the Sun sets in the west, Mars rises in the east. Towards midnight, Mars, in opposition, is due south. Mars glows yellow among the white stars. When the Earth is between Mars and the Sun, Mars is opposite the Sun. At noon, we see the Sun due south. At midnight, it's Mars we see due south. Mars is the only planet astronauts will be able to walk on in the near future. In 1976, a probe landed there to take samples and analyze them. Other probes are on their way to Mars. As we travel around the Sun, we forget that the Earth carries with it an enormous cone of shadow, 12,000 kilometers wide. We shouldn't forget because every evening when the sun sets, we enter this shadow to spend the night. During a lunar eclipse, which always happens on a full moon, we can finally see the shadow of the Earth projected on the moon. Lunar eclipses happen 2 weeks before or after a solar eclipse. While solar eclipses can be seen only in a very narrow zone and last only a few minutes, lunar eclipses are much easier to see. When the moon faces the sun, it plunges into the Earth's shadow. Because the Earth's shadow is much wider than the moon, the eclipse lasts for hours and can be enjoyed by everybody on the dark side of the Earth. Earth casts its shadow on the full moon. The sun's rays, filtered by our atmosphere, bathe the moon in the colors of sunset.